Many times designs evolve from what might have started as a solid body might actually be made from sheet metal. Other times, the geometry of a sheet metal part is too complex, and designing it as a solid is much easier. Either way you go, SolidWorks has a convert to sheet metal command that will allow you to create a flattenable sheet metal part from a solid very quickly and easily. So to get started, let me show you what we're going to be doing. So right here you can see we have this solid, and we're going to create a sheet metal part from it, and that is going to look a lot like this part here. So you can see we used that original solid and then created a sheet metal part around it. And then my other example here is going to be this part here, which starts as a non-sheet metal part, and we convert it over to a sheet metal part here with bent edges. So those are my basic things I'm going to be using and creating. So let's go ahead and close this one here. Let's leave this one open, and let's go ahead and also close this part here. And we'll start from this one right here. Here's my example. So the first thing I want to do is head over to the sheet metal tab and say convert to sheet metal. So the first thing I want to do is choose my fixed entity, which I'm going to choose as the bottom surface right here. All right, now let's choose the thickness. So I'm going to type in 0.063, and my bend radius is going to be 0.30. And here's my bent edges. So I want to start from that fixed face and start bending from there. So I'm going to choose this edge right here. Notice it gives me a representation of that first bend. Let's just work our way around the part. And notice it's showing me the ripped faces here as well as the bent edges. And let's choose the surface right here. How about that guy right there? And click on the inside edge here, and notice this ripped edge is just kind of following us along, and there it is. All right, so now we have all the edges selected. SolidWorks does a great job of specifying the default radiuses and the gaps, and we can modify those if we'd like to by changing them in over here, or we can come down here. You can see where all the ripped edges are found, and you can modify these gaps if you'd like to. So let's make a really small gap, so like maybe a 10th thou gap, and let's make our overlap 1.0, so it's a full overlap. And as far as the K factor, let's go ahead and just leave it as K factor for right now, but you might want to go back and change that to a bend deduction value later. But keep in mind, we do have one edge here, or one bend here, that is not a standard 90-degree bend, so that is going to have a different K factor or a different bend deduction than the other ones, so you might want to go back and modify that one individually. Same thing down here with the auto relief. It's set up as tear, but you can also switch that to maybe like an all-round or any other style you'd like. And once everything looks good, go ahead and click on OK. And there is our first sheet metal part. Now, of course, there's nothing really connecting these edges together, so you might want to come back later and do a weld here, or extend these flanges, or do a closed corner type of setup. But either way, we have a sheet metal part now starting from a solid, so you can really create some pretty complex geometry very quickly by starting from a fairly complex solid and then just quickly converting it over to sheet metal. This would be a lot harder to create if you just started from sheet metal in the beginning. Now let's switch over to my other example, which is right here. And this is a basic part. So most of the time you'd see something like this that would go out for manufacturing. It was designed like this, and the shop would say, hey, this would be an optimal part for sheet metal. Let's go ahead and convert that over. Let me show you how to do it. We're going to pretty much do exactly the same thing, convert to sheet metal. As far as my fixed face, let's go ahead and just choose this one here. My bent edges, let's go down here and choose this edge here. Let's choose this entire big bend right here, and this little guy over here. All right, now we have that. Let's define the thickness of the material. I'm going to type in 0.125. And keep in mind, you can change the thickness different from what you started with. So notice over here, I can make this as big or small as I'd like. Notice the little preview, it's showing very thin material here, but you want to generally make it fairly close to the thickness of the existing part. So this here is the same, but it does show you that the material is going to be kind of rounding in here. Our bend radius here of 30 thousandths should be just fine. Our bent edges are shown here. Of course, we can modify the other things down here. But once everything looks good, click on OK. And now we've very quickly converted a non-sheet metal part quickly into a sheet metal part. And I can click on flatten, and you can see there is our flattened state. Click on flatten again, and it folds it right back up. So very quickly, a convert to sheet metal command can easily take a solid or a part that's designed as a kind of a mock sheet metal part and turn it into a real sheet metal part that can be flattened out.